Coming up on Destination Tomorrow, we take a look at the first century of powered flight. We'll look back at how two relatively unknown bicycle makers from Dayton, Ohio, beat many of the world's foremost thinkers to become the inventors of the airplane. Plus, we will see what the future holds for aviation in the next 100 years. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
On this special episode of Destination Tomorrow, we'll look back at the first century of powered flight and the pioneers who designed and built the world's first flying machines. And we'll discover what the future might hold for aviation.
Throughout history, man has always been intrigued with the idea of flight. However, most early aviation pioneers could not imagine flight as we know it today. With limited understanding of basic aerodynamic principles, many of these early pioneers attempted to build flying machines that were shaped like and emulated the flight of birds. The crude structures that they built generally relied on feathers and flapping wings as the catalyst for flight, ultimately leaving a trail of broken men and machines. History is inundated with stories of these birdmen jumping from towers and cliffs in a vain attempt to fly. Flight attempts gradually moved from small feathered devices toward larger structures, yet many of these attempts still ended in humiliation and sometimes even death. However, with all of these failures, early inventors were building a foundation of knowledge for the future of flight.
Although many had tried to build machines that could fly, all earlier powered flight attempts had failed before the flight at Kitty Hawk in 1903. Though the Wright brothers were the first to fly a heavier-than-air machine, people had been airborne long before the Wrights' first flight. The Montgolfier brothers conducted the first public display of a hot air balloon flight near Paris in June of 1783. Balloons were also used extensively during the American Civil War to observe enemy positions, but balloons could not be controlled very easily, so the search continued to find a system that would allow heavier-than-air powered flight. In the late 1700s, Sir George Cayley of England helped define the problem of powered flight when he observed the problems of lift and drag of birds. Through a series of mathematical calculations and use of a device called the whirling arm, he tested numerous wing designs and eventually published many of his findings, providing a solid basis for flight pioneers of the future. One of the most notable pioneers that profited from this information was the German glider designer Otto Lilienthal. Lilienthal was often referred to as the Birdman because his glider designs were generally shaped like birds or bats. In his lifetime, he built 16 different glider designs, testing them from a man-made hill near his home. Unfortunately, he died August 10, 1896, after the glider he was testing spun out of control. His last words were, "Sacrifices must be made."
Building off of the work of others, Orville and Wilbur Wright began working towards their goal of building the first heavier-than-air vehicle.
In June of 1899, the Assistant Secretary of the Smithsonian received a letter from Wilbur Wright asking for reading material that related to heavier-than-air flight. In his letter, Wilbur wrote that he was an enthusiast, but not a crank, with some pet theories of his own about flight. A few weeks after his letter was received, Wilbur received a package from the Smithsonian containing reading material and suggestions referencing virtually every text in existence that mentioned flight.
With this information in hand, the Wright brothers started their crusade to build the first viable heavier-than-air ship.
To help us understand how the Wright brothers accomplished their goals and how their early planes flew, Johnny Alonso finds out how it works.
On the morning of December 17, 1903, history was made off the sands of Kitty Hawk, North Carolina. For the first time in history, man had achieved controlled flight of a heavier-than-air machine. The Wright brothers had achieved what all their predecessors had only dreamed of, flight. While many of their contemporaries had focused on very complicated designs, the Wrights chose a straightforward design as a means of accomplishing flight. Controlling the aircraft was a key area most designers took for granted. This is where the Wright brothers targeted most of their design and innovation. Most early inventors thought that flight control can be achieved by a pilot simply shifting his weight back and forth. The Wrights, on the other hand, knew that controlling the plane would be the key to successful flight. To find out how the Wrights accomplished the goal of flight, I spoke with Jim Cross to find out how it works.
Well, it started when they were both pretty young. In fact, at the time they were living in Cedar Rapids, Iowa. So they didn't always live in Dayton, even though that's where they considered their home to be, Dayton, Ohio. Their father was a minister. In fact, he was a bishop in his church, and he would take long trips away from home. And when he would come back, he'd often bring the boys a gift. Well, one time he came back from a trip and he walked into the room and had something in his hand. And when he opened his hand to show him what it was, it flew out of his hand. Now what he had brought him was a little helicopter, I guess is what you'd call it today. But at that point, Orville was only 7 years old at the time, Wilbur was 11. That seed of flight was planted, and it never left them. They really just started sort of as enthusiasts and hobbyists, but when they got started on it, they knew before they did anything, they were going to have to learn everything they could on it. In 1896, they decided that they were going to get involved and take an active part in trying to solve this problem of flight. Now, they were in their 20s at the time, young men, owned a bicycle shop, the Wright Cycle Company right there in Dayton. But what really propelled them was the death of Otto Lilienthal. Now, he was a great German glider pilot. He had made thousands of glider flights. When the Wrights heard of this, they took a look at this and they said, you know, how is this possible? How could he possibly have something go so wrong that it could cause an accident that he could lose his life in? And at that moment, they decided that they wanted to maybe get involved to see if they could figure this out. At first, they didn't have this idea of they're going to go out and invent an airplane. Their initial idea was simply to study the problem, to learn everything about it they could, and what their hope was to be able to come up with possibly some little tidbit of information that they could add to this body of knowledge that man was accumulating. And then they figured someday somebody's going to put it together and figure this out.
The Wright brothers recognized early on that the pilot would have a very limited range of motion in which he could shift his weight. They realized that a pilot would become fatigued quickly if he was constantly adjusting his weight to control the craft. They understood that movable surfaces would be the only way a plane could be controlled. Wilbur Wright came up with the solution quite by accident. As he was talking with a customer in the bicycle shop, he was fidgeting with a small cardboard box. As he twisted the box back and forth in his fingers, he realized the same principle could be used on an aircraft's wings. This idea came to be known as wing warping, allowing the control they've been looking for. They tested the idea on a kite glider and were pleased to see how well it worked. With this discovery, the brothers were well on their way to solving the mystery of flight.
The Wright Cycle Company right there in Dayton was really a key. A bicycle at the time, late 1800s, was cutting-edge technology. Now, a bicycle is an unstable piece of machinery. If you just get on it and sit there, you're going to fall off. Now, even if you start riding it, if you want to turn, you can't simply turn that handlebar. But if you lean a little into that turn and then turn the handlebar a little, you're making the turn. Same thing with an airplane, they figured. So control was the key. That's what they were going for.
In the fall of 1900, the brothers tested their first glider design on the Windy Dunes here at Kitty Hawk, North Carolina. Although the test flights were somewhat successful, the aircraft needed more design modifications. For the next 3 years, the brothers would leave Dayton for a few months out of the year to test their new designs at Kitty Hawk. In the late summer of 1902, the brothers finally had a glider that worked well.
But that was a turning point for the Wrights. At that point, they were no longer hobbyists. They were no longer enthusiasts. They were now true scientists and engineers. They had entered a whole new realm.
All that was left to do was find an adequate engine and propeller system, and they felt that they would soon be flying. Unfortunately, automobile engines of the time were not up to their exacting standards. So in typical Wright fashion, they hired their friend Charles Taylor to make an engine especially suited for their needs.
The engine weighed 180 pounds, and it gave them 12 horsepower. That's 50% more than they needed. So they had that engine. Now that was a 4-cylinder, gasoline-powered, water-cooled engine. I mean, it worked great.
With the engine problem solved, they looked to the propeller. For years, the Wright brothers assumed that the propeller would be the easiest problem to solve on the aircraft. Their original design was based on a ship's propeller, but they ultimately found that this design was not sufficient for their needs.
The Wrights were the first ones to figure out that a propeller for an aircraft truly needs to be a rotary wing, something that can create lift. And you just rotate that 90 degrees, you got thrust.
After months of tackling complex mathematics and theoretical physics, the brothers designed their own propellers.
Now, they hand-made these propellers out of laminated spruce. They put all of this together on the craft, and when they were done, they had a unique piece of machinery, something that could do what no other machine in the world had ever done before. They were confident of that, they knew it, but they had yet to prove it.
After winning a coin toss to decide who would try first, Wilbur climbed into the plane December 14, 1903. Unfortunately, this first flight attempt failed, causing minor damage to the plane. So 3 days later, after repairs had been made, it was Orville's turn to attempt flight.
Now, as they were getting ready to launch that craft, Orville and Wilbur kind of went to one side and had a little short conversation. The witnesses said when they left, they shook hands like two people that may never see each other again. Now they come back, he gets on board that craft, lays down in that pilot position there. Now Wilbur's got to take his place out on the wing. They're ready to go. Orville releases that wire and that craft starts down the rail. Wilbur's running along, holding onto that wing, keeping up just fine until at 10:35 in the morning, 17 December 1903, it lifts into the air. And for the first time in the history of the world, we have controlled, powered flight. First flight, 12 seconds, only went 120 feet. But it was truly the first controlled, powered flight by man. Now they made 3 more flights that day, total of 4 flights, and they alternated. Wilbur made the 4th and the longest flight. The 3rd flight was only 200 feet, but the 4th flight was 852 feet in 59 seconds. That really proved it to the world that they had really done it. What have we seen since then? I mean, we got a space station in orbit right now. I mean, we put a man on the moon. We have literally come from Wilbur's footprints in the sand right here to Neil Armstrong's footprints on the moon. Now, when Neil Armstrong landed on the moon, he had with him, had it tucked inside a spacesuit, he had a small patch of cloth from that original Wright Brothers 1903 powered flyer. And I can think of no finer tribute to the Wrights than that.
That's all from the Wright Memorial. I'm out of here. Oh, but before I go, did you know that Orville Wright was not only the first person to fly, but he was also involved in the first fatal aircraft accident? The first person killed in an airplane accident was Lieutenant Thomas E. Selfridge. On September 17, 1908, airplane inventor Orville Wright took Lieutenant Selfridge up on a demonstration flight for the U.S. Army. During the flight, one of the propellers separated, causing Wright to lose control. The plane fell 75 feet to the ground, killing Lieutenant Selfridge, while Orville Wright suffered a broken leg and pelvis.
Full-scale models of the Wright Flyer have recently been tested in NASA wind tunnels as well. Up next, we'll find out how flight has progressed since 1903. But first, did you know that the original Wright Flyer was first housed in a British Science Museum from 1928 until 1948? The Flyer was first offered to the Smithsonian Institute in 1910, but Smithsonian officials declined the offer, contending that the former Smithsonian director, Samuel Langley, had in fact built the first airplane capable of flight. Incensed at the obvious slight, Orville Wright assembled the aircraft and allowed the Science Museum of London exclusive rights to display it. The disagreement between the Smithsonian and Orville was resolved after the Smithsonian offered a public apology stating the Wrights were in fact the first to fly. The dedication of the Wright Flyer in the Smithsonian Institute took place on December 17, 1948, 45 years after its first flight.
After the Wright brothers provided a template for flying machines, aeronautical breakthroughs were achieved at a relatively quick pace. In fact, only 66 years after the first powered flight, the Apollo 11 spacecraft became the first manned spacecraft to land on the moon. This and many other amazing achievements were due in large part to the work done by NASA and its predecessor NACA, or the National Advisory Committee for Aeronautics. From its humble beginning through today, NASA has truly changed the way we all live. By 1915, the United States was already falling behind the Europeans in aircraft design and manufacturing. To stem this tide, President Woodrow Wilson asked that an aeronautics organization be developed, modeled after the British Advisory Committee for Aeronautics. With only a $5,000 initial appropriation and 12 unpaid members, the National Advisory Committee for Aeronautics was born. Its mission was to supervise and direct the scientific study of flight here in the United States. With the first aeronautics lab at Langley Field opening for business in 1917, aviation would soon be entering its golden age. From 1917 through 1958, NACA was responsible for many pioneering flight achievements in history. NACA was involved in virtually every area of flight and would soon be known as the foremost aeronautics lab in the world for its pioneering research.
I had heard about it when I was in college because two of my aeronautics professors had worked at Langley, and they said that they thought all aeronautical engineers ought to work at Langley for a couple of years for that experience. Well, I went there for the couple of years and then stayed for 35.
One of NACA's first major accomplishments came in 1922 with the construction of the Variable Density Wind Tunnel. Before this tunnel was built, researchers could only test aircraft models at sea level, which left huge gaps in the understanding of aircraft performance at high altitudes. With the new variable density tunnel, NACA researchers for the first time could compress air and simulate high-altitude flying. This provided accurate data for aircraft manufacturers, greatly improving the quality of aircraft being produced. The variable density tunnel was just the first of many NACA and NASA wind tunnels to come. NACA wind tunnel research helped define and alter many problems that early aircraft were experiencing in flight. Through the 1920s and 30s, this research helped engineers with breakthroughs in cowling research and in new wing designs. However, some of the most important work in NACA wind tunnels came at the dawn of World War II. Just a few short years before the U.S. entered World War II, it was found that many of the aircraft that American pilots were flying were slower and less maneuverable than the aircraft that their future enemies were piloting. In an effort to find a low-cost way to increase American aircraft performance, NACA engineers began evaluating aircraft in drag cleanup experiments. By placing an aircraft in a wind tunnel, engineers could look at the entire area of the aircraft and determine which area could be made aerodynamically smoother. This evaluation process greatly improved American aircraft performance. During 1 month alone, July 1944, 36 U.S. Army and Navy planes were evaluated in detailed studies of stability, control, and performance. All in all, NACA engineers tested 137 different airplane types between 1941 and 1945, either in wind tunnels or in flight. A typical performance improvement was seen on the Navy's F-4F aircraft. When Langley researchers streamlined the U.S. Navy's Wildcat, it was able to fly a full 45 miles per hour faster. Improvements like this were seen in virtually every aircraft evaluated, undoubtedly saving many lives. After the war, a large part of NACA's focus turned to jet-powered aircraft. With the success of Chuck Yeager and the X-1, America had once again taken the lead in aircraft design. In the years to come, NACA researchers would make key aeronautical breakthroughs in quick succession. Many believe that the freedom that was given to engineers to explore possibilities fueled many of these great breakthroughs.
I give plenty of credit to Langley because they provided so much for me. I could never have done what I did without the Langley Research Center. They provided vast amounts of money and equipment, personnel that were required to demonstrate these ideas. One of the things I mentioned was the fact that when I first had the idea of the area rule, having the idea was not, to me as an engineer, as important than putting the thing in a wind tunnel and demonstrating that it worked. And without the NASA, anything that I ever wrote on the damn thing would be in a file somewhere.
NACA's mission changed on October 1, 1958, when it was absorbed into the newly formed National Aeronautics and Space Administration, or NASA. This agency was formed primarily to focus on solving problems related to spaceflight, but would also continue to focus on aeronautical problems as well. Researchers at NASA have continually been on the forefront of aeronautical exploration. In fact, virtually every American aircraft, commercial and military, have been tested in some way by NASA researchers. This strong history of aeronautical research continues today and will continue in the future. Jennifer Pulley spoke with Bob McKinley at NASA Langley Research Center to find out what airplanes might look like in the near future.
Not long after the first flight at Kitty Hawk, the Wright Brothers, and many other inventors for that matter, began trying to find ways to make aircraft better. In a relatively short amount of time, aircraft designs went from canvas and wood structures with very weak engines to metal structures with very powerful engines. With each new innovation, propeller-driven aircraft became stronger, safer, and much more efficient. The next great revolution in aircraft design came with the development of the jet engine. This type of engine truly changed air travel dramatically. It enabled aircraft to fly farther and faster than propeller-driven aircraft, while improving safety and efficiency. However, since the beginning of the jet age, technology innovations in aircraft have been more incremental than revolutionary. Small steps forward have continued to make flying safer, but what will be the next great revolution in air travel? To help answer this question, NASA researchers are working on new designs that could change air travel once again. New aircraft shapes, cleaner burning fuels, and new materials could be the first steps in the next revolution in aircraft design. I spoke with Bob McKinley in the Vehicle Systems Program Office at NASA Langley to find out what future aircraft might look like.
The Vehicle Systems Program Office is focused upon working on improving the aircraft of the future. In particular, we want to work on quality of life for the citizens of this country, and that's where our investment is aimed, and also to make aircraft safer and cleaner and better for the environment. Some of the aircraft that we're working on would be subsonic transports like jetliners that would fly quieter, land and take off quieter, and supersonic aircraft that could fly over land without making a sonic boom, and personal air vehicles that you and I could use in place of an automobile.
Now, will the aircraft of the future look similar to the aircraft we see today?
Some aircraft will look the same as what we see today or very similar, and some will not. One of the concepts that we've been working on in terms of advanced technologies is the blended wing body, or the BWB. And that aircraft is aimed specifically at being much cleaner in terms of emissions and fuel burn.
Current aircraft are much more efficient and quieter than aircraft designed, say, even 30 years ago. But public demand for quieter and more environmentally friendly aircraft continues to grow. In an effort to meet this goal, NASA is researching an aircraft called the BWB, or blended wing body. The BWB is a hybrid shape that mainly resembles a flying wing, but also incorporates some features of a conventional transport aircraft. The futuristic airframe is a unique design with efficient high-lift wings and a wide airfoil-shaped body, allowing the entire aircraft to generate lift and minimize drag, thereby increasing fuel economy.
In addition to the blended wing body, we are working on aircraft that would cruise at a higher speed. Today's planes fly at between 500 and 600 miles an hour. We call it Mach 0.85 is about the standard. And what we'd like to do is move to an aircraft that allows us to fly at Mach 1.6 to 1.8, which is over twice as fast, say 1,200 miles an hour. And you'd be able to get from New York to LA in about 2 hours. Now, the technology exists to do that today. We have supersonic aircraft. We could make aircraft that would efficiently cruise at that speed, and the Concorde is an example. Aircraft like that can't fly supersonically over the United States or over any landmass because they create a huge sonic boom as they do so.
A sonic boom is a noise similar to thunder, caused by an object moving faster than sound, about 750 miles per hour at sea level. As an aircraft travels through the atmosphere, it continuously produces air pressure waves, similar to the water waves caused by a ship's bow. When the aircraft exceeds the speed of sound, these pressure waves combine and form shock waves. These shock waves are heard as a sonic boom when they hit the ground. This boom is so disturbing that aircraft today generally only break the sound barrier over water or in restricted military space. But new testing at NASA might soon change that. In recent tests, NASA researchers successfully demonstrated a way to lessen the impact of a sonic boom.
Flight cleared, high altitude supersonic, entry exit point 1, advise and complete to the corridor.
They found that by designing the wings and body of an aircraft to a specific shape, the pressure waves generated can be kept from merging together. The resulting shock waves are therefore much weaker in strength, and the sound heard on the ground is less intense. With this new breakthrough, supersonic flight over land may finally be within reach. Another program that NASA researchers are currently working on may completely revolutionize the way we currently commute and travel in our daily lives. One of the major breakthroughs for personal travel in the 20th century was the development of the automobile. Before the automobile came along, the average person would only travel 5 miles a day or less. This number increased to 50 miles a day with the development of the automobile. The goal of the personal air vehicle is to enable the average person to travel about 250 miles a day by using their own or a shared personal air vehicle. The hope of NASA researchers is that personal air vehicles will be used in the 21st century the same way automobiles have been used in the 20th century. This change would allow much more mobility and freedom in our everyday lives.
These aircraft may be able to completely displace the automobile, just as automobiles did horses. And we're looking at those in three phases. The first being what we call a quiet, conventional personal air vehicle, be very similar to what you see out on general aviation runways today. We hope to make these aircraft so easy to use that almost anyone would be able to take a few hours of training and get in and use this vehicle to get anywhere they want to go. The second phase would be what we call a vertical or short takeoff and landing air taxi. And this would be an aircraft that could take off in very short distances and hold 6 or 8 people, and you'd be able to just walk up like you do a taxi at a taxi stand and say, I need to go from Washington to Cleveland, and you'd be in and go. The third phase, we'd get into what we call a dual mode. And this would be, if you think Jetsons, this is the flying car. You'd be able to park this thing in your garage, drive out on your street, roll down the street a little ways to some short takeoff field, and fly. And maybe it's as simple as take me to grandma's house, and it knows how to get you there. You know, we've come a long way since the Wright brothers took their short flight at Kitty Hawk. There have been a lot of innovations in aircraft technology in just a short amount of time that we've been in the air. And NASA's been a big part of that. And we're going to continue to be a part of that in the future.
That's it for this special edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.